All right, so we're going to solve question 24. And this is trying to figure out the resistance of a conductor. Everything has resistance, even your conductors have resistance that we need to account for in our circuits. So though they let electrons flow quite nicely, everything has a little bit of resistance. So for this particular question, we're solving for resistance. We have the length of our wire, which is going to be proportional to the resistance of that particular conductor. We have the CMA of our conductor, and we can find that in the last page of our practice final. We can cross-reference on that chart. 20 gauge wire is going to have a CMA of 1022. And we're dealing with copper, and the resistivity of copper is 10.4. I like to remember it by, if you're on a radio and you say 10.4, that's how I remember that. Anyway, 10.4 ohms of resistance per mil foot. That's the resistivity of copper. So we can use that formula we learned, R equals K, which stands for resistivity, times length. And so our resistance here is going to be proportional to the resistivity and the length of the wire. And it's going to be inversely proportional to the CMA, the area in circular mils of that conductor. So the larger the conductor is, the more easily electrons can flow through it. So it makes sense that it's going to be inversely proportional to our resistance. Either way, now it's just a matter of filling in our formula. So our K is 10.4 times 2,200 feet, and we always use feet for this equation. And our CMA is 1,022. Plug that into the calculator, and you get 22.4 ohms. So our answer there is A. And these equations can be found in module A1 if you want to, toward the back of A1 if you want to study that if you're having trouble with these and want some more questions to work on.